How do you find the areas between two curves? What do you do? Subtract what from what? The bottom curve from the top curve? No, it's the other way around. Top minus the bottom. Is that what you're saying? Okay, that's right. So it's the top curve minus the bottom curve. But it switches in this graph, right? So if you're in the green part, the area of this bit is going to be, that's f of x, the integral of f of x from -2 to 0 minus the area of g of x from -2 to 0. Does everybody agree with that? And our integration is that, dx. Then we will add the area of the blue bit. But the blue bit, what's the top curve? It's g of x, right? Because it switches. G of x is the top part in the blue. So it'll be g of x minus f of x. And what's my boundaries? What are my boundaries? 0 to 2. All right, so let's do this. So you have two separate integrals that you have to do. So the green stuff. Oh, you're right. I should have a d of x there. Thank you. So integral from -2 to 0. F of x is 3x cubed minus x squared minus 10x minus, as soon as you're subtracting a whole function, what do you need to remember to do? Bracket, right? Or remember to carry the sign. I'm going to put brackets. Yeah, they should have dx's. Thank you. So now we have to simplify before we do the integration. So the green bit, 3x cubed. There's no other 3x. There's no other 3x cubed. So it's -x squared minus -x squared. What does that become? 0x squared. So they're gone. -10x minus 2x is -12x. So that integral got a little easier. And the blue one, -x squared. Oh, sorry. 3x cubed plus x squared. Those go away. 2x. Area between curves. Why? There's only one x cubed though. Right? Oh, the x squared? Yeah.
Is there any context or is it just 2 lines?
This stuff.
Okay. It's like a velocity time graph.
Oh, no. It's just a made up question. All right, what do we do, peoples? What type of functions are these? Polynomials, which are the easiest to integrate, right? Because you just add one to the exponent and divide by that number. So if we're doing the green, we're going to get 3x to the fourth over 4 minus 6x squared, evaluated from -2 to 0. And then the blue bit is going to be -3x to the fourth over 4 plus 6x squared, evaluated from 0 to 2. And then you know what? You're going to figure out the answer, because I'm not going to do that. I know what the answer is, but... Well, you're going to have to do this on your test, so... Yeah, if he wants you to do area between curves, he'll give you the graph. I hope. What do you mean? Well, just do the green all by itself. The 0 goes in. Oh, like this? Think of it as the top curve minus the bottom curve. So the top curve in the green part is f of x, right? And you're subtracting the bottom curve, which is g of x. So then I just punched in those functions. Does that make sense? Okay. Anybody get an answer? Well, really, do you have to worry about the zeros? No, they're going to go away, right? So $28. Well, I have the answer here. I got 24. 24 is the answer, peoples. Not an objective opinion. Okay, here, I'll do it. All right, so if I put zeros in, I get 0 minus, then you got to put -2 in. Okay, plus, put 2 in. And I don't have to put the 0 in because it would be 0. Okay, so this is all I have to do with. -2 to the power of 4 is positive 16, right? Positive 16 divided by 4 is 4 times 3 is 12. So I got negative. That whole thing turns into 12. -2 squared is 4. 4 times -6 is -24. Plus this whole thing here is going to be, that's the same as this essentially. But you're going to get -12. And then that's going to be 24. Why did I do what?
Like I just plugged in zeros. Like I got 12 and negative 12. I got 12 and negative 12.
2 squared. Are you talking about this one?
I don't know why you got negative 2.
I'm putting in negative 2 in.
Why are you using negative 22?
Those are the numbers. I have a feeling it's. Hang on. I think it's negative, yeah. So I'm going to get negative 12 plus 24 minus 12 plus 24. Yeah, negative. Yep. No, it's positive. Yeah, it is, because I'm going to get negative 24 plus 24 plus 24. 24. It's positive 24. Put your hand up if you got positive 24. There you go. It's positive 24. Oh my gosh. Yes. Because you put the 0 in and then you subtract when you do the second one. That's why. Because you put the 2 in first. All right. Here's what I want you to do. Page 442, numbers 3 and just do number 3. number 3. What Torsten calls first/second. So it's when you have a function defined as an integral, which is a weird concept. I understand that. Okay. But basically, some functions are defined as the area under curves. Okay. The one that you will see next week is the natural log function. It is defined as the area under the curve from 1 to whatever x is of 1 over t. So now you don't have to memorize this or anything. This is the graph of 1 over t. If I say that's 1, and that's x, that area represents natural log of x. So when somebody says, what is the natural log of 2? What they mean, or what is happening, is it is the area from 1 to 2 of that graph. So when you punch natural log of 2 in your calculator, and it gives you 0.69, it means that area is 0.69. That's just one function of a bunch that can be defined as an integral, okay? That's all the natural log function is. It's the area under the curve 1 over x. So when you say natural log of 5, it's the area from 1 to 5 under the curve 1 over x, okay? All right, you don't need to know any of that stuff. What you need to know is how to take the derivative of a function that is defined as an integral. And he did that today, right? He showed you the shortcut. He gave you that crazy big function, and he showed you the shortcut. That's what you need to know how to do. All right, so we're just going to practice that. So the derivatives of these things. Because there's one of these questions on your test. So if I have a function that I'm defining as gonna do it the long way, and then I'll show you the shortcut. So we have our function f of x, which is the area under the curve of the cosine function from 0 to x. So if I just asked you to integrate the cosine function, what would you get? What's the antiderivative of the cosine function? Sorry? Sine x? If I just ask for the antiderivative of cosine, it's sine, right? And since it's a definite integral, we would evaluate it from 0 to x. Which number do you plug in first? The x. And then you subtract sine of 0. What's sine of 0? 0. That's 0. So you just get sine of x, okay? Basically, so capital F of x is equal to sine of x. So then when I say, what is capital F of x primed? You would tell me cos x. What's the shortcut to go from there to there if I say take the derivative? That's it. Okay? Because I'm saying the antiderivative of cosine, not the derivative of cosine. I'm saying the derivative of what function gives you cosine? And the derivative of sine gives you cosine. Yeah, oh, yeah, they would cancel each other, right? Because the derivative and the antiderivative are opposite processes. So when you take the derivative of an antiderivative, they just cancel each other out. So if I gave you something like this, f of x is equal to 2 to x of, what's a good function? Three t squared. So I gave you that. And I said, what's f prime? There you go. Okay? Now, you can just dump it in without even thinking as long as the top one is x. All right? If it's not x, so if it looks like this, I don't know, 7 to, we'll do cosine again. We'll go do it the long way, and then you'll see the shortcut, okay? Cos t dt. What's the antiderivative of cosine? Sine. Evaluated from 7 to 3x squared minus x. Which one goes in first? Top one. So I get sine 3x squared minus x minus, and you put the bottom one in, sine of 7. And then I say, so that's f of x. Oops. What is f prime of x? Capital F prime of x. So what rule do I need to use on the sine? Chain rule. So what's the derivative of sine? So I get cos of 3x squared minus x times what? That's exactly it, 6x minus 1. Now, sine 7. What's the derivative of that? 0. Why is it 0? because it's a constant, right? So that's just 0. So this is just my answer. So the question is, 1 second. How do I go from here to here without doing the intermediate stuff? What do you do? What's your instinct to say to do right away? Plug this in for your t, right? But what do you have to multiply by after that? The derivative of whatever that is. Okay? So if I give you a question like, f of x is equal to, I don't know, 2, 2, 3, 3x. We'll just do 3x. Of, I need a good question. So and then I say, what is f prime of x? What do you do? Three x goes in for your t. And then what do you have to remember to multiply by? 3, the derivative of 3x, which is just 3. That's all you need to be able to do. What if I said find f double prime? We're not going to do it for this one because it's going to turn into a gong show. But what if I said find f double prime? What would you do then? Just take the derivative of this. Okay? Everybody good with that? All right. Page 290. Numbers 81 to 91 odd. Number 87 is a bit tricky. So I have the answer written out up here if you want to see it, but go for it. Those are your questions to do. It is break time. We're 5 minutes late. You can go on break now. And then on the other side, we got a couple other things to do. All right. Trapezoidal rule. So I think Torsten explained this, some integrals cannot be solved or are very, very, very difficult to solve. So we approximate them using, well, this case, trapezoidal, but there's other rules, but we're only learning trapezoidal. Okay. There's one called Simpson's rule where you use quadratic equations to approximate the area under the curve. That gets a little messy. So we'll just stick with trapezoids. All right, so the trapezoid rule, he's not going to give it to you. You got to remember it. All right, it's not that complex. All right, he went through the derivation. I'm not going to, but if you want me to later, come see me and I'll show you where it comes from. But this is the formula. The integral from a to b of f of x dx, i.e. the area under the curve, is approximately equal to, little wavy equal sign. Yep, approximately. b minus a over 2n. Okay. Times, we'll talk about what all these mean. x0 to, oops, sorry, not x0, f of x0. Plus 2 times f of x1 plus dot, 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 dot. F of x n minus 1 plus f of x n. Okay, what the heck does that list? Because there could be an infinite number depending on how many trapezoids you put under the curve, right? Just like the rectangle thing I showed you the other day, the more trapezoids, the more accurate your answer. He's not going to make you do anything over like 5, I think. Did he say 5? Yeah, okay, so 5. All right. Mhm. Sorry, what? Yes, f of x1. Yeah. Okay, the only trick to this formula is the first term, f of x0, and the last term, f of xn, have coefficients of 1. Every other thing in the middle has a coefficient of 2. Okay? This is basically the width of the rectangle. Okay? So this is, trapezoid. This is the width, and these are all the heights. That's where they come from. Not that you have to know that, you just have to know the formula. N represents what? Number of trapezoids, right? Okay. What example did he do? Did he? Did he do sine? Let's do sine x. X1. This one? N minus 1. It just means the second to last one. That's all it means. Let's do sine x, because we know what that one is. So we're going to do the integral from 0 to pi of sine x dx. And we're going to pretend that we don't know how to do that using definite integrals. Okay? So, approximately equal to. What do you want the n value to be? Let's do n is equal to 4. N is equal to 4. Okay. Oops. So what's my b value? Pi, the top one, right? This is pi minus my a value, which is 0, over 2 times 4 times. Now this is where you have to do a little bit of thinking. This is the only trick in the trapezoidal rule. It's not even a trick, it's just something you have to think about. So what I do is I go, okay, we're going from 0 to pi. Whoa, not 4, pi. I need 4 trapezoids. So I got to divide it into 4 sections, right? So if I divide it in half, what is that number there? Pi over 2, right? Does that make sense to everybody? If I divide that in half, what is that? And what's this? Three pi over 4, right? That makes sense to people? You have to equally divide them because these numbers are your x0, x1, x2, x3, x4. All right? That's what goes into these things. Okay? So I'll write it out. So the first one is going to be f of what? F of 0 plus 2 f of pi over 4 plus 2 f of pi over 2 plus 2 f of 3 pi over 4 plus what? F of pi, right? I don't put a 2 in the last one. Once you do this a couple times, it kind of just flows. So this little bit on the outside here, pi minus 0 over 2 times 4 is pi over 8. Now it's f of 0. What's my function? Sine. So it means sine of 0 plus 2 sine of pi over 4 plus 2 sine of pi over 2 plus 2 sine of 3 pi over 4 plus sine pi. And then you get your calculator out and you start doing things. But does anybody remember their trig from Math 12? What's sine of 0? Oh, people. So the sine graph looks like this. Looks like that, right? Sine of 0 is 0. So that is gone. What's sine of pi? Peoples. That's pi right there. That's 0, 2. Can anybody tell me what sine of pi over 2 is? What's pi over 2 in terms of degrees? 90. What's sine of 90? It's right there. So it's 1. So that one's 1. So you really only have to do those two. And I want a decimal, please. I do want a decimal. Because we're approximating it. C. Well, you could. Oh, you mean once you get to this part here?
Yeah.
Yeah, you can do that.
No, like that.
The only thing, these would turn into halves if you did that. The first and the last one would have a half in front. Yep. But you'd have 1/2 F0, which in this case is easy because it's 0, right? But that's not always going to be the case. Anybody get an answer? That's what I got. So there's a 65% chance that's wrong. That's more on me, Jacob, than you. All right, that is correct, though. All right, 1.896. People get that? What mode must your calculator be in if you're adding rads? Are you guys all in rads? Are you putting it in rads or are you putting degrees into it when you're doing? Okay. 1.5, did you multiply by pi over 8?
Am I supposed to add
Add in the 1. Yes. Yeah. Because it's this number plus that number times that number. Okay, that's another thing. Multiply by 2. Oh, yes. There you go. Because it's 2 times 1, right? Yeah, so plus 2. So you should get 1.896. Because we are superstars, we actually know how to do this, right? I'm not sure. Okay. Anybody know what cos of pi is? 1, yes. Cos pi is -1, actually, sorry. Sorry, Letitia, I got your hopes up. Because the cosine graph looks like this. There's pi. So it's -1. So -1, what's cos of 0? 1. So I got 1 plus 1, which is 2. This is just how to do the question. This is how you would normally do the question, because we know how to do this integral, right? So if you actually do it, the actual answer is 2. We used only 4 trapezoids, and we got an approximation of 1.89 or 1.9. So we got pretty close. How would you get closer? More trapezoids, right? It's the same thing as basic integration. So, rectangle. Trapezoids look like this. That's a trapezoid. That's a trapezoid. All right. Are we okay? You're going to have a trapezoidal question on your test. So here's what I'm going to ask you to do. I'm going to ask you to do question page 310. You do number 1, number 7, and number 9, please. They say to use trapezoidal and Simpsons. Don't do Simpsons, just do trapezoidal. They tell you what the n value is. Yeah, once you just practice it a few times, it should be okay. He will not give you the formula. You need to remember the formula. Okay? I'll give you a bit of time to work on that, and then I'll talk about all the reviews that I'm going to push out to you guys for this chapter, and then on Friday, you're getting all your course reviews. And we'll talk about the final exam on Friday, my final. Okay. But for right now, just do those trapezoidal rules, and we'll talk about reviews in a bit.